where we at? We're at week 13. So we're closing in on the end of it here. And PowerShell intro part 2. So you're basically just supposed to pick up where we left off last week, until the end, that PDF in the presentation, and then a couple of exercises. So hopefully not too much of a workload. Let me get my I guess before I start going over the PowerShell stuff, is there any question on what was due this week? Anything that any questions you have on last week's stuff, hold till the end. But you can certainly ask questions, as we're going through, if you don't understand some of the commands or the concepts that we're discussing. The other thing that I will do at the end for anyone that wants to stick around is go over assignment 6D. Now, I've posted the video review, and so I'm not going to say much more than probably what's in that video. I think it's, it became available at, on Monday. So, but if you can't ask a video question. So if you want to stick around and you want to ask questions, or you didn't get enough out of the video review, then do that at the end, going over that last Python assignment. And then if you have any questions about last week's PowerShell assignment, we can talk about that as well. Okay, any questions before I continue?
None come to mind right now.
All right, so we're just gonna go through here. The first topic is redirection in pipes. Can everyone see the PowerPoint text okay? Okay.
Yeah.
If it, because I can't tell for you if it's blurry or anything. I can make it a little bigger, but if I make it much bigger, then they, start to scroll off the screen. Okay, so redirection, you probably used it in other classes, depending on the classes you've had. And it is just a way to send output generated by a program, or in this case, a PowerShell command, to redirect the output. Instead of sending it to the screen, it sends it to wherever you specify, generally a file on disk. It's used a lot in Linux, not quite as much in Windows because one's tied to the GUI, but it's used a lot in computing in general. Redirection is. There's both redirect output to a file, and there is the opposite. You don't see it used as much, and that is, instead of a greater than sign there, which says redirect the output to this file, there you can put a less than sign, and that would tell the program, or in this case the command, to get its input from a file. So again, that's not used as often, but you'll see it periodically, again, probably more in things like Linux. And it's basically, instead of a user having to enter a bunch of stuff at the console, if you pre-populate a text file with the input the user would have generally had to type in, then you can use the input redirection symbol. All right, so just use it as an example. Oops. All right, so obviously when you redirect your output, you're not going to get any output sent to the screen. If you want to see what you just, the file that you just created, the get content, PowerShell way. All right, so there's the output, the file that was created from the get child item. And that's get content in this case is really no different than using like the command prompt type command. Okay, the same thing. Or in Linux, it would be the cat command, CAT, or the more or less commands in Linux, but more and less do one additional thing, they paginate the output. Which reminds me, you can also, of course, use, and we're going to, use this pretty soon, but you've probably already seen me use this, and you probably already used it, the pipe symbol, and piping output to the more command, which paginates your output. Okay, and then the double greater than just appends data to the file if it already exists and has data in it. Okay, so if you don't want to overwrite your file, just use the double greater than. Okay, and then piping, as you just saw with what I did with the more command, it basically takes the output from one command and sends it as input to another program or command. Okay, so that's different than redirection. Redirection, sends the output to a file, whereas piping sends the output to another program or another command. So, in this case, I'm just using get child item to pipe it to the more program to paginate the output. And in this case, we are going to use the pipe symbol to pipe the output from get child item to the where object command. And so piping is used extensively in PowerShell. You will see whenever you're looking at examples of PowerShell, and you'll use it in the assignments, lots and lots of piping, sometimes 2, 3, 4 chained pipes, where you're piping the output from one command to another command, and that gets piped to yet another command, and so forth. So they can get, the commands can get pretty big and multi-line commands with all the piping and redirection that is commonly used. So let's look at this particular one. The where object PowerShell command is really, it's definitely a command that is specifically used for piping operations. It's not a standalone command. So you would never use where object as the first part of your command, or at least I can't think of a situation in which you would. So it's definitely a special command that is used for piping, for taking the piped output from another command. So in this case, what it's doing is it's sort of self-explanatory, and that's kind of the nice part about PowerShell is because the commands are rather verbose, long, but they're also somewhat self-explanatory. They, in many cases anyway, they kind of give you an idea based on their name what it is they're doing. So the where object is saying, given the input that I've got, look at the objects that are being generated by getChildItem. And for any object's attribute name that looks like file asterisk, then it's basically filtering. It's filtering the output of getChildItem and only going to show me things that start with the letters FILE. So when I run that, I think I probably had to create a file called files.txt, or I actually created it with the earlier command when I redirected the getChildItem to files.txt. So where object is basically a filter. It lets you do a immediate search through the information that's being generated by another commandlet and just limit what's being shown or what's being created to your specifications. All right, so and it's using name. Name has to, of course, be one of the attributes of the objects that the getChildItem creates. And it, of course, is the name of the file. All right. And besides just being able to redirect data to a file, you can also assign output that's generated by any command. You can assign that output to a variable. So in this case, I'm going to create a variable called file content, and it's going to store the results of getContent files.txt. So now file content contains everything that was in files.txt. Okay, sort of like, just like very similar to the Python command that we used when we did the read lines to get the content of that CSV file. And so, you can also look at file content and say, see what is inside it. And let's see if I can find some of the content. Yeah. So each line of the output from getContent got stored as a separate element in file content. So it's essentially an array of lines of text from files.txt. Okay, and then to show piping again, the output, we're going to pipe the output from getProcess to the outFile commandlet. And outFile is just what it says. It basically just sends whatever is given to it to the file you specify. So it's really just like using the redirection. So this command here is identical in function to using the redirection and going to processes.txt. I think outFile has some additional parameters so that you can, in some way massage the data that gets produced before it gets sent to the file. I haven't worked with outFile that much, but you can always do a get help on the outFile commandlet to see what it's capable of doing. One of the things that it can do, of course, is append, and that's no different than using the double greater than sign in redirection. And so we get and there's get processes, as you might expect, is sort of like the PS command in Linux, for those that have had Linux, or it's basically like looking at a static version of Task Manager and going to the processes tab of Task Manager. So that's get processes if you want to see it in text form rather than in the Task Manager GUI. Okay, so one of the things that we mentioned.
Sorry.
Yeah.
Real quick, is that you said it was static, so it wasn't gonna, those numbers won't move for the processes?
That once I do the get process command, it gives me a snapshot of the the CPU usage and the memory usage and all that. Unlike Task Manager, where
Right, it's constantly moving and stuff.
yeah, it's real time.
Okay, thanks.
Mhm.
Sorry, I know you were moving on, but thanks.
Okay, so obviously there's a lot of, fair amount of information produced by this get process, but really not nearly as much as is actually available. Where do I have get process? There we go. So this is just sort of like the default information that get process shows for processes. If you want to find out all the details about get process, there's the get member command. And get member basically is like the dir command in Python. If you looked at my the PDF version of the PowerPoint that I posted, I had ls up here instead of dir, so I must have had Linux on my mind or something. But if you remember, when you're in the Python console, you can type dir and then in parentheses put any object type like a list or a string, and you'll see all the methods and attributes of that object. And that's what get member is similar to. So get member will show you, in this case, all of the attributes and related functions and related methods of the objects created by get process. Okay, so, and I keep on saying objects, that's because everything in PowerShell, everything that's produced is referred to as an object. And it's pretty much the same thing as the Python programming language. A string or an integer or a float, they're all, some type of value, but they're also objects because they have related attributes. And same thing with everything that's you see in PowerShell. So here's all the various attributes of the get process, of all the objects created by the get process. So, these are attributes that you would typically display. And then there's methods. So you know what a method is. You can, if you took an object created by get process, you could call one of these methods. For example, if you took one of the objects created by get process, then each object is going to be a running process that's loaded in Windows in this case. And you could call the close method and it would attempt to close that process, essentially terminate it, or kill, would attempt to kill that process. And then would attempt to start
So
it.
would close act like you're exiting out of the program and it might run in the background, but kill would like quit the program?
Good question. I would have to look closer at exactly the difference between close and kill. My guess is that for a well-behaving process, they'll do the same thing, but kill, if the process doesn't respond to close, then you can use kill on it to force it to be removed from running memory. But that's just a guess. I would have to look up the details on the close method to be sure. There's so many methods, and I don't know, half of them, or not even probably a tenth of them, because there's so many different object types and so many attributes and methods associated with them. When I need to do something with a object, then I look it up. Use get member to find the methods available and the attributes available and the various properties or whatever. And then if it's not self-explanatory, then I Google it, just like anybody else would. Okay, so these are all properties of. So you can display more about processes than than the default display. But generally, when you run a command that gets information about something, there's some just default properties that are displayed. And then if you want to know more about it, then you can use get member to see what the other properties and so forth and attributes are. And then we'll see a little bit later how to display additional information about an object. Okay, and then like other things in PowerShell, there's an alias for get member since it's frequently used. So I don't need to actually use the example I have up there. Get this is a string. I can just put double quotes, and just like I could do double quotes with the dir command in Python, and do and pipe it to get member, and it'll tell me all the methods available for any type of string object in PowerShell. So, some of these are going to look somewhat familiar with methods that you saw in PowerShell, in Python. There's more, seems like, from my estimation, there's more methods available for string objects in PowerShell than there are in Python. And I don't know what all of them do. I can only kind of figure out the ones that are kind of obvious and self-explanatory. But obviously, the ones that we used are like to up, or similar to upper, to lower. There's a to int. So if you had a string that contained a number, you could convert it to an integer. And then we have split, which does just pretty much exactly what the split method does in Python. By default, just like in Python, split will create in this case, they don't call it a list, they call it an array, but it's the same idea. It'll create an array based on the spaces that it finds in the string. So it creates, this is a string. And of course, you can assign that to a variable. And you can access individual elements of the array that's created. Okay. So, you know, similarities between just about any programming language. A lot of, you know, various programming languages have their own unique features and functions, but most modern programming languages have at least a bunch of things in common. So when you go to learn a new programming language, and you know, okay, there's got to be a way to, you know, turn a string into an array separated by, you know, some delimiter like a space or whatever. And so you just kind of look up the documentation of that programming language to see if there's something similar to the split method. You know, there probably isn't for every programming language, but for a lot of the ones that are used today, there probably is. Okay, in exercise 8.1, let's see if I can find that in PDF. I don't think there's not really that much that's difficult there. Yeah. Here's the exercise. So create and save a text file with Notepad called address that has your address in it. So you can just run Notepad from the command line. It'll open Notepad up. And since you started Notepad from, you know, in my case, users gtom show, then any file I save will get should get created there. So if I wanted to have my address, I'll put my work address. Then save it as address.txt. Thought it would save it where I'm currently at, but apparently it's not going to. All right, so there's my text file, and then assign it to a variable and display the contents, right? So the contents, so what would I do in order to assign the contents of address.txt to a variable called address?
You could redirect it.
Could you redirect it? I don't know if you could or not. What would your command be?
Could you use the greater than signs?
So what would your full command be?
I don't know.
Okay. What I would probably use, and there may be more than one way to do this, is use the get content command like we did before, and then just say get content address.txt. And so that's going to, instead of getting the content and displaying it to the screen, it's going to instead store it in the address, in the variable address. Okay. And then I'm not sure what the multi-line string variable $work address with your work address. Not sure what they are wanting there. To work out what method. Okay, so let's just skip 3 because I'm not sure because I don't use that work address again. So I'm not really sure what they had in mind. It sounds like whoever wrote that exercise had something in mind and then changed their mind because they don't do anything with work address after line 3. So we'll just look at
Gotta
line.
love it.
What's that?
So you gotta love it.
Yeah, it happens, I guess. So we'll go on to number line 4. Create a variable with your name. And a pipe symbol and GM to work out what methods to make it. So basically they want me to convert it to upper or okay.
Are you able to move your window up at all?
This window.
Yeah, can't see what you're typing.
Can you see it now?
No.
Huh. What's the last thing you see?
1100 East Sheldon.
What? Oh, really? Wow.
Yeah, it's weird.
Is anyone else seeing?
No, I see it just fine. Is your window size maybe like smaller? Maybe you have your window thing in on a full, but I don't know. I see mine just fine.
Like, do you have it?
I got it to work, sorry.
You have it windowed and you had to scroll. Yeah. Okay. Okay. All right. So yeah, I skipped part of what they asked to do, but basically use get member to see the methods to upper and to lower. That's basically what they wanted you to do here. Okay, and there's like trim. Trim is what did they call it in? Did they call it trim in Python? Sometimes. Anyway, trim basically gets rid of empty space, like spaces in the front and end of a string. So a lot of the same type of things that you could do with strings in Python, you can do with PowerShell as well. Just a second. Okay, so let's see, that's 8.1. Let's see what else. All right, so scripts. A script is just, taking a bunch of these PowerShell commands, putting them in a file with the extension PS1, and so that they run, just like a Python program that you put in a file and you run it. So PowerShell, like Python, isn't restricted to just entering commands at a command prompt. You can create pretty complex scripts to do stuff for you on your computer. So, in this case, it says to, look at listing on page 28. Let me see if I can bring that listing up. Or listing 28. So it's talking about this. And comments, like Python, use pound sign to start the comment. So anything after the pound sign is ignored. So what they're going to do here is get today's date and store it in a variable, and then ask for your name, and then barf back out to you your name and the current year. Okay, so there's not much to it, but the key here is going to be that in order to run a script in PowerShell, you're going to need to do what I mentioned in that announcement. Unless your PowerShell is already configured appropriately. But if you try to run a script in PowerShell with the default settings, PowerShell by default, or Windows by default, restricts the running of scripts. And so, so it doesn't allow them, period. So you have to, well, let me do the part where I get the execution policy. So there's something called an execution policy, and the get execution policy command will tell you what the current policy is that's in effect. And if yours says restrict or restricted, I can't remember exactly how it's specified. Well, actually, we can do this. So sorry, in order to see, you need to get help on the that execution policy. So here's the options: all signed, bypass, default, remote signed, restricted. So most likely, yours says restricted or default, which is usually restricted on Windows machines. So in order to be able to run scripts, if you use the set execution policy bypass command, and you know, this is, you don't have to do that, the dash execution policy. It's assumed that that's what you mean if you use one of these as the next parameter, but you can put it in there if you want, the dash execution policy or option. But in any case, if you say bypass, what that will do, it will bypass restrictions for the local machine. And that means for any type of script that was run from the local machine, it will still restrict your computer from running PowerShell scripts if you, for example, were to click on one on the, you know, in a link on the internet, or try to run it from a remote server. Okay, so those would still be restricted. But for our purposes, just having bypass the local machine is sufficient. And you still have a modicum of security, since you can't run scripts that are from a remote, from some remote entity. But when we're done, you can always set the execution policy back to restricted if you want. If you want to, you know, essentially go back to that secure option. Okay, so I'm going to go ahead and, you know, let you do this little bit about if you want to just experiment with using scripts. You can type the stuff in listing 28 into the ISE, save it, and then run the script by clicking the run button. But if it gives you an error, it's because you probably need to do the set execution policy to bypass. Mine's already set that way, so I don't need to redo it. Okay, and the 9.1 does something very similar. You may or may not, for just for having additional practice, you might want to go ahead and do it, but it's up to you. But I definitely recommend that before you start writing your own scripts, which you'll have to do in one of the assignments coming up, that you make sure that they work by typing one in that is given to you as an example. Okay, so next topic is logic and loops. And here's where PowerShell looks a lot more like C than Python. The if statement, the condition, first off, indentation doesn't matter like it does with Python, because curly braces delimit the code blocks. Whereas in Python, it was the indentation that delimited the code blocks. So in PowerShell, some of the difference between PowerShell and Python is the condition in an if statement has to be enclosed in parentheses following the keyword if. Okay, that's something that you can do in Python. Python won't yell at you if you enclose the condition in parentheses, and I find myself doing that frequently since I write some C code and I'm used to using parentheses, but it's not required in Python. It is in PowerShell. And then to start the code block, you have an open curly brace. And by convention, you indent your code, but it's not necessary. But I would do it because it makes it more readable. But if you put your code right up the same margin as the if statement, it would work just fine. But you shouldn't do that just for readability's sake. And then you close a code block with the closing brace. And then you've got else ifs, just like you do in Python. And finally, else statements. But each if, else if, they all have to be started and ended with your curly braces. All right.
Do they have to be on separate lines like that?
No, but they should be, just for readability's sake again. Some people do their open curly brace right underneath the if, and then they put the next else, so it looks like. So this is another way to format it, but it doesn't matter. You could put everything all in one line if you wanted to, but it would be much more difficult to read. So that's how I wrote C code when I used to write a lot of C code. To me, that's cleaner and easier to read than the way it was before. But you have to find what works for you. A lot of people do the open curly brace on the same line as the if, and then if there's an else or an else if, they put it right following the closing curly brace of the if. But it doesn't matter as long as you have the open and closed curly braces in the right, in the right place in terms of with respect to the other code, then it'll work. So you could put it all in one line if that's what you really wanted to do, but I wouldn't. Makes it difficult to read that way. All right. Okay, so as I mentioned, has to be enclosed in parentheses. Just, you don't have to have else ifs and else. Only put them in there if the logic requires it. Actually, yeah, I guess in Python it's elif, not else if. It's abbreviated in Python, but else if in PowerShell. That's the one difficulty of going back and forth between languages is you get, little variances in the syntax mixed up in your head. and I frequently do, because I go between Python, PowerShell, and then like C++, and even other things like VBScript and stuff like that. And so I have to frequently look up the syntax of whatever code I'm writing, unless I've been, using just that language for several days in a row, because I forget, well, does it do this way or does it do it that way? So yeah, it gets, you want to learn as many languages if you like programming and you think it'll be useful for you. You want to learn as many as you can, because different languages come in handy for different things. But mixing them up on a daily basis starts to mess with your head. At least it does with me. Okay. All right, so that's pretty much it for the if statement. So here's a big difference in how your comparisons work in your if statements or any of your conditionals. So you'll want to pay attention to this table and kind of try to commit it to memory as best as possible. PowerShell does not use symbols for their comparisons. They use dash, and then usually, I think, almost for the most common ones, they use a two-letter symbol. So EQ for equal, NE for not equal, GT for greater than, LT for less than, LE for less than or equal, GE for greater than or equal. Okay, and then these are different. There isn't an equivalent in Python, at least as a direct comparison. There's a library function that you can call that does something similar to like in Python, but there isn't. It's not part of the built-in language. So like is just what it sounds like. Like is, I used it in that earlier command where I said where object name like file star, and that file asterisk means it starts with give me any files whose name starts with FILE, and then it can be 0 or more characters after that would be a match. And then there's the opposite, the not like. Okay, so those are two, new comparison operators available in PowerShell that are not available in Python. Okay, so let's just look at some examples, and we'll just copy and paste those in. And just like in Python, a comparison will return true or false. Greater than or equal to 20, yes, false, I mean. And then here's the use of the cat. So what could I do to make this true by just changing something here and not making the R a T, but to do something besides making the R a T? What could I do instead?
Would you use the NE command?
No, I'm asking what can I change just with the string CAR star to make it true with the like comparison to cat? What can I change here?
Can I presume the asterisk? Would you like get rid of entirely, or would you?
Now, if I got rid of the asterisk, then
It would just go back to.
yeah, see, or if I, to be false. But if I get rid of the R, if I just say CA star, that's basically saying cat like CA, and then the star means 0 or more characters are similar. Okay, so cat CAT is like CA star because star means match 0 or more any type of character. And so in this case, the CA matches, and that's good enough because the star means will match T, it'll match pretty much anything. If I do like the next statement, if I do catamaran, well, that's going to match too because the star means 0 or more additional characters. And then, like, well, this one is not like, and it'll be false because catamaran is like CAT star. Okay, so the asterisk is just a wild card. It just means 0 or more characters of any type, and it'll be a match.
Is it only for that placement, like where the asterisk is, like for example, like 1-to-1 of like a letter, or is it the entire like length of a word?
This means starting, it means starting at the T or after the T and any other characters. So let me change this to like. So this is going to end up to be false because it's got to start with CAT, but then after that it can be anything. This is going to be true because CAT star matches CAT anything. Okay.
Okay.
I'm pretty sure that the question mark is valid. So if I did this, okay, the question mark matches one character and only one character. And so that's why cats matches, but if I did and cata matches. But if I do CATAM, it won't match because the question mark is one character and only one character. If I put 2 question marks, then it would be a match. Okay, so asterisk means 0 or more. Question mark means 1 and only 1 character. That can be anything. It could be any character at all. All right. So yeah, to give an example, set course to CNT190, dollar course like CNT star, then enroll. Of course, that isn't going to. The enroll now isn't an actual commandlet, unless I made it one. You can actually create your own commandlets in PowerShell, which are essentially scripts that have been turned into commandlets. But I didn't do one for enroll now, so it doesn't exist. And just like in Python, you've got a for loop. And the for loop is the syntax is very much like C, C++, C#, any of the C language. And Java as well, I think, uses a similar for loop syntax. So in the for loop syntax, it always looks like this. You set a variable to an initial value, for example, 0, if you wanted to count from 0 to 9, then your counter would be equal to 0. Condition is, what value of the counter or any other condition, but usually your condition involves your counter. what value does it have to reach before the for loop is done? And the step is how much should I increment my counter each time through the loop? The typical increment is by 1. So to take that into an actual for loop that does something, put it in here, and you see it goes from 0 to 9. So again, this says initializes I to 0, and the condition that will make the for loop stop is that let's say the condition that will make the for loop keep going. So as long as I is less than 10, the for loop is going to continue. And then I'm going to increment I by 1. That the plus plus is shorthand for I equals I plus 1. Or I plus equals 1 in Python is the shortcut version in Python. So plus plus operator is something that's new. It just increments the variable, the numeric value by 1. If you wanted the step to be 2, whoops. If you wanted the step to be 2, I think this works. I'm not 100% sure that's correct syntax or not, but we'll find out. Yeah. So you would, now that's more like Python, but C and all the C languages in PowerShell have adopted the plus plus shorthand for incrementing by 1. Okay, do you understand that then? So each time through the loop, I starts at 0, it writes the 0 out, goes back to the top of the loop, checks the condition. Well, I is still less than 10, so it's going to continue the loop, and then it does the increment. In this case, it increments by 2, writes out the 2, goes back to the top of the loop, checks the condition. I is still less than 10, so it's going to do the increment again. It's going to be 4, 6, 8, and when it hits 8, then it goes back to the top of the loop, and or after it hits 8, after it writes 8, then it increments by 2, and since it's now 10, it's done with the loop. Okay, so I kind of made you think that it checks the condition first, but that's not right. It does the increment first, increments the variable, then it checks the condition. And if the condition is now false, which once I is equal to 10, I is not less than 10. So the condition's false, so it quits out of the for loop. Okay. Identical to this in Python. I in range 0, 10, colon. Okay, so for each is a new type of for loop. It's very similar to the just using the for variable in Python, but you have to use for each if you're going to want to iterate through a list and assign each element of the list to a variable. So let's see what this does. Again, get child item is essentially the same as doing a dir. It gets all the files that are within the current folder. So in this case, we assign the output of get child item to the variable files. which is now essentially an array of files. And then this for each statement is going to basically get each item from files one by one and then assign it to the variable file. And then we're going to write host just the name of the file. So it goes through each of the files produced by getChildItem, assigns it to file, each one in turn, and then the write host command writes just, in this case, just writes the name. Okay. If I didn't do the .name part of the command, it would write the entire I guess to just do, yeah. I thought it would write, give me more information than just the name. No, that doesn't. If I wanted something besides just the name, I'd have to see what attributes are available. So you could say $file get member and display various properties. So to do that, $file. So the name is sort of like the default property that gets displayed in the write host command, but you can also do bunches of other properties. Full name is read-only, the length, access time, all these different properties. You could replace this with, if I just wanted the length of each file, or just give me the length. And if you look at listings 29 and 30 in the PDF file, let me bring them up, you'll see some additional examples of using if statements. You make sure you want to study these listings in addition to the ones that we specifically go over. And notice in this one, you don't have to increment or add to your your counter variable in your for loop. You can subtract to it just as easily. Okay, so a couple of for each. You also want to maybe look at listings 31 and 32 in the PDF that do some additional stuff with. They use some what they call hashes that we call dictionaries, or what Python calls dictionaries. So you might want to look at those examples just to get some more practice looking using the for each loop. I'll show you what I'm looking at, and using hashes within them. Okay, so let's look at the date and time functions available. So get date returns, just if you just do get date, it returns a formatted date and time. But there's a lot more that you can ask PowerShell to do than just display the date and the time as it is. If you put the command in parentheses and then put a dot after the parentheses, then you can specify a specific property of the object created by that command. So that just gives you the hour. In this case, the hour is in 24-hour format. So 19 instead of 7. And you can use variables, and you can, in this case, let's do this. Variables, and then we're gonna subtract the variables. That'll give us the amount of time elapsed between now and then. And notice how, since we did a basically an arithmetic function on here, PowerShell was smart enough to kind of know what we were up to and what we wanted. We wanted the difference between the time generated by get date here and get date there. And it displayed essentially the get date object, and at least several of its various properties. So the amount of time that elapsed between the first get date and the second get date was 7 seconds, 304 milliseconds, or 7,073,043,626 ticks. The total number of days was 8.45 blah 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 times 10 to the -5th, and 0.0002 hours, 7,304 milliseconds. All right, so a lot can be gotten from the get date rather than just a formatted date. You can get, you know, you can display just individual properties and also use arithmetic on them to see.
What purpose would this be for? Is this for network time protocol, or what?
Yeah, it would be, let's say you wanted to, because I use a bunch of these when I wrote a program to generate a report every Monday or something like that. I can't remember the details of what I did, but if you let's say you wanted to write a program that accessed the one of the date parameters of a file, like the last access, and you wanted to go through your directories and find any file that was accessed in the last 10 days, or any file that hasn't been accessed for 6 months or something like that. And then maybe, you know, if they haven't been accessed in 6 months, you go and continue your script and send them to an archive folder or something like that, assuming that they haven't been accessed in 6 months, then maybe you know, they don't belong in primary storage or something like that. So lots of things you can use them for, looking at not just the get date, but any type of time and date object that is produced in PowerShell. You can, one of the things that you're going to be doing is looking at processes, running processes, and listing all of the processes that have taken up, you know, more than 2 seconds or something, some number of seconds of CPU time. But all of the dates and times that are found within PowerShell and within the objects within PowerShell use a date and time type of object. And so you can, you know, write programs to take advantage of that fact. Find any process that's been loaded for longer than so many days or hours, or find any process that's taken up more than a certain amount of processing time.
So could you use this to write a script to say, if it's been 30 days, clear out all user profiles.
Yep. If
Okay,
if it's been 30 days since the profile has been used or something like that.
right.
Yeah, so you would probably, in that case, have to go and look at the files in the profile to see the most recent last access date. And then if that last access date is more than 30 days, then do whatever it is that you wanted to do with it.
Okay,
Okay.
thanks.
Mhm. All right, so the get member tells you all the methods. So you can take a date time object is what they're referred to, and you can do addition to the various properties. You can add days, hours, seconds, milliseconds, whatever. And then here's all the, there's bunches of them. I don't know what all do, to be honest. Convert things to local time. And then here's all the properties: date, day of week, day of year. So yeah, you can get the day of year. So I can say, whoops. $now.day of, so this is the 111th day of 2021.
You mean the 477th day of 2020?
Or you could say that, since it's still feeling a lot like 2020. Okay. Yeah, and then obviously, if you want to know more about how to use get date, then and then you can just say dash detail, dash full, dash examples if you want to just see examples of using get date. So it's creating a timestamp for files. So if you might want to look through some of the examples to see various ways to use that command. And then again, that will apply to any date time object that PowerShell might display in other get commands, like the get process or the get child item, like the access time. So these like last write time, see how it says date time? So those are all date time objects. So they can be used just like the objects produced by get date. All right, 10.4 exercise has you write a script with a hash of people and their birthday, and then you add a question to ask for a person. So you do an input to ask for a person's name and return the birthday for that person. So again, I'm not collecting these that are built into the PDFs. They're just good short little exercises to do to give you practice in doing using various commands. All right, and so we looked at some of these. If you see that, if you want to find, just like we did in Python, we had the type command. There's a method, oops, for any object type. And so you see that then returns a date time object. And then if we say difference, the difference object returns a time span object. And so that's a slightly different type of object. And if you do member, then you can see it looks like it has a lot of the same, but fewer methods than a date time object. All right. So a time span object, similar but not quite identical to a date time object. 11.2, I told you to skip it. I guess there probably wasn't. Yeah, I mean, you could do it if you want. It's basically asking you to calculate how many seconds, minutes, hours you've lived. So basically, you do to do that, you would say, you know, dollar now, date, and dollar then. Let's see, how do you create a date time object? Like this. So you basically cast and you then just basically put your date of birth. Let's see. I think it's in this format. Is that going to work? Oops. It's misspelled date time. Okay. So let's see what dollar then looks like. All right. So I don't think I was born exactly 12 a.m., but that's good enough. So then you say dollar now. Oops. Is equal dollar now. So 21,520 days I've been alive. Plus 19 hours, 53 seconds, 53 minutes, 27 seconds. And 756 milliseconds. Anyway, so if you want to know how many total milliseconds you've been alive, however many that is, what is that? Wow, that's thousands, millions, billions, 1 trillion, 1.8 trillion milliseconds. Okay, so I think the last section here is working with files. Actually, we've worked with files, you know, by get content and so forth, and by creating them. You can read this on your own. We're not going to deal with CSV files, but PowerShell has the capability to specifically work with CSV files to put them into essentially a multi, just kind of like with Python, we had to read the CSV file in, which, comma separated value file. We had to read it in, and then we would split it based on the commas, and it would create a list for us of the items. Well, with PowerShell, there's an import CSV command that specifically knows how to work with comma separated value files. And so you don't have to use the split command and do all that to get them into a proper array. So if you want to read about that, then you can, because knowing how to work with CSV files, since that's a common file format, any kind of Excel spreadsheet or something you can save as a CSV, and then you can use a program like Python or PowerShell to manipulate the contents of that file. And the import CSV just kind of skips having to do the split and get those elements into a multi-dimensional list. Python actually has a CSV library as well that'll do something very similar. We just didn't use it since I wanted you to use the split command to manipulate the data. Okay, but you're not going to be tested on it, and we won't be using them in any of the assignments. So that's kind of for you to do on your own. And that's pretty much it for the intro. There's one more lesson file that we'll be looking at later, but this is it for the majority of PowerShell. So from that, we've got a exercise, and the exercise is basically, like a lab where it tells you everything you need to do. You just basically type in, and since obviously you can copy and paste, and it saves you typing, but you're doing yourself a disservice if you do that, because you remember the commands and the purpose of commands much better if you actually have to type them yourself. Copying and pasting, your brain just doesn't remember stuff nearly as well as if you actually type it all in. So I highly recommend that you do a little extra work and type the commands in rather than copying and paste them. So you basically go through this, and it has you use a lot of pipes, introduces you to some new commands like get service, which is what it sounds like. Gets the services that are loaded, and you can also use the where object can be abbreviated as where. But in any case, so you can get a list of running services based on the status, or get a list of services that are disabled, or any other status that you want. And then have you chain a few commands together with multiple pipes, introduce you to a few other things like format list. You'll see what that does. And format table, which you can abbreviate also. So doing these not only is good practice for commands that we've already talked about, but also introduces several new things. And you're going to need what you learned from here, from doing this exercise. It's a pretty long one, 27 steps. And then you're supposed to upload the script file and the file that gets created to the assignment. You're going to need that for doing the assignment. So the exercise teaches you what you need to know for the most part. And then the assignment has you take what you learned, and turn it into your own script to do something slightly different. Okay.
I have a
That-
question about that one.
Mhm.
I was trying to do it and I couldn't get the CPU time to show up in seconds whenever I was redirecting it or piping it.
Okay. Well, what you'll want to do, you'll want to find the properties of the both the get process and the date time objects. What did you use in order to try to get the seconds?
I was just trying to put parentheses with an S after CPU. I think I was doing it wrong. Like how it was listed in the process.
Yeah. The only thing that I found, or the main thing that I found that might be challenging, was how to find the total used physical memory, because the property that the name of the property that stores that wasn't exactly self-explanatory. So I give that to you there. Yeah, I think you're just going to have to play around with the date time object that gets returned in order to extract the seconds from it. Okay, if you have, if you work on it between now and tomorrow and you're still having trouble, then just join me in the office hours from 10:30 to 1 if you can. Or if you can't do that and you need to make another time, then just email me and tell me what time you would like to, or give me some possible times, since I may not be able to, make it your first choice time to do a Zoom session together. And I'll try to help you out.
Thank you.
Okay, but I think, I give you some hints down here on some of the stuff that might be useful in doing this assignment. Okay, so what about last week? Any questions on stuff from last week? It was basically just like 4 commands you had to come up with. I graded some of the ones that were already turned in, but I don't think I've graded ones that have been turned in late. So
I felt like I had to write it out in a notepad or something, then paste it in for it to accept. If I typed it out and press it enter, it wouldn't work for some reason.
Really?
It would just go to the next line, next line, next line.
This was in the PowerShell. Was it in the PowerShell window or the ISE?
PowerShell window, yeah.
So just this guy that I had up here.
Correct.
Okay, so let's.
And I don't know, maybe my code was wrong or something, but
So
I had to write it out somewhere else and then paste it in for it to be, I guess, correct. I don't know.
So the first one is get command and
It wasn't for all of them. It was for the scripting one. Hold on, I'd have to look at it again.
But you did get it to work, right?
Yeah, I did get it to work. It just, I had to copy and paste it in for some reason.
Yeah, it's kind of strange. Okay. Any other questions on this assignment? Okay. All right, so anyone want to go over assignment 6D, which was the last Python assignment? So
I'm just waiting for it to be graded. I resubmitted it.
okay, yeah, I got a little bit behind this week and I haven't gotten everything graded that's been submitted since sometime last week. So does anybody want, like I said, I have the video review that goes over it, but if anyone wants me to go over this, my version of it, then you can stay. Otherwise, if you don't need to do that, you can go. Unless you have any questions.
Thank you.
Sounds good. Have a good night.
All righty, see you around.
Thank you.
Can you just scroll through and I just want to compare mine side by side?
Yeah. What I'll do is, I think
Well, I can watch the video. I mean,
a
you
lot
don't
of it
have to.
self-explanatory up the top here. So obviously at the beginning here, I do the import, then I ask the user for the file name, and I strip any extraneous characters from what they may have entered. It's not kind of optional to do, and then I that's just in case they lean on and just enter spaces and hit enter. That way length will be 0, or if it's exit. And then I open the file using try except, and if it doesn't work, I just quit. Create my socket, read the file, close the file since we're done with it. And so I'm going to go ahead and go to here. All right, so this is what things look like up to this point. That's the red dot is a breakpoint. So when I ran it, stops at my breakpoint. So at this point, the contents of the file is just, just exactly what the file looks like, with /n representing the new lines. And then data list is the list that gets created from the list comprehension here. Okay, so it creates a bunch of lists inside of a bigger list. So each line of data is its own list. And the file descriptor doesn't matter, file name, right? So, and then I'm gonna delete data, the first row of data list, or the first item in data list, to get rid of the headers. And the next place I stop is unpacking the rows. So the row is going to be basically the first line of data in list format: the IP address, the port, the name, and the message. Okay, and so this syntax unpacks that list into these 4 variables. So IP address goes into IP adder, the port number goes into port, and so forth. All right, and then of course I split the IP address so I can get to the various octets, so I can do the validation. So here I make sure that I've got 4 octets, and I make sure that each octet is numeric. And again, there's different ways.
Was that print line necessary?
Which print line?
The invalid IP address? If not,
No, it's not. That wasn't necessary.
okay, sorry.
No. I just put that in there, just so that if, when I was testing it, when I test my program, of course, you want to always put, if you're validating the data in your file, you want to put bad data in the file to make sure your validation works. So I would, when I was testing, I would put some bad data into the test data one, you know, an invalid IP address or an invalid port number or something. And then the print statement would just give me feedback. Oh, yeah, it caught a bad IP address or something. But it wasn't necessary in your program to put that in there. Okay, and so if there's anything wrong with this check of the IP address, then I just continue. That means we're skipping that line. That's all. Continue means go back up to the for loop and get the next row in data list. Otherwise, now I'm going to check the validity of the or now I'm going to look at octet 1 to make sure it's in the proper range for a first octet, to make sure it's less than 224 and greater than 0 and not equal to 127. And if it's any of those things, again, it's invalid, so I continue, meaning get the next row of data. Okay, if it gets down to here, that means the IP address so far, or the IP address is good. I actually don't go and check for the class. I'm not sure if you needed to or not in the final program, but I didn't do that in my version. I just validated it. If you check the class, that's fine. But the important thing is that you validated it, that everything was in proper range. I didn't check the octets to make sure they were all between 0 and 255, which you could have done. Okay, and so if we get down here, now it's time to make sure the port is in a valid range. And if it's not, continue, meaning can't process that line, so we'll get the next line of data. And then if we get down here, that means that the port's good, and we put it into our tuple, the IP address and the port into the tuple, concatenate the name with the message with a colon in between. And again, this print statement is unnecessary, but I've just put it in there just for my own feedback. And then send the message. Okay, the encode. You can always encode it before and just put message in here as long as you encoded the message, you know, saying message equal message.encode. But that wasn't necessary since you don't use the message again, the encoded version again, then you can just encode it in the function, in the method, the send to method. And then bump up our counter by 1 for the number of processed lines of data. So, because if there's anything wrong with the IP address or the port, then the continue will make it skip all this stuff and just go back up to the next, get another row. And it'll also skip the incrementing of the successful variable. And then once it does all the, goes through all the lines of data, then it prints out how many were processed and how many, or how
Totally
many.
forgot about that counter.
What's that? You forgot about the counter?
Yeah.
So you need to have the counter. The counter was just something I just wanted you to add to it so that, you know, that's something that you would normally do in a program. If you're processing a file and it's possible that you're going to throw some lines out, it's always a good idea to know how many were successful and how many were bad. And you know, in a real program, you might even print out the bad lines, like sort of like I did up here. I just printed out the bad parts if there were any bad parts, but in in real life, you might actually print out the entire row variable to show that that row wasn't processed because there was something invalid about it. But all you need to do in this case was increment a counter, assuming that line got processed. All right.
I got it mostly right.
All right, that's good. All right, any other questions on anything? Okay, next week we just have a little bit more PowerShell to read and another exercise quiz. Then we're pretty
Thanks
much
for going over that.
yeah. Then we're after next week, we're pretty much done with any new stuff. It's just going to be studying a final PowerShell, couple PowerShell exercises, and studying for the Python final, and that's it. There won't be a PowerShell final. I'm just using the 2 quizzes and the assignments as the for your PowerShell part of the grade. All right. Anything else? All right then.
Thanks again, Greg.
Need anything? Hit me up during office hours tomorrow, or like I said, send me an email.
Thank you. Take care.
Okay, you too. Bye.